Hi there, I'm Michael Cohn from Advanced Tubular Technologies. I'm the developer of VTube laser software that measures tubing and then qualifies tube shapes and corrects tube bending machines. In this video today, I'm going to be measuring this 1.5 inch square diameter tube. And the first thing I'm going to do is import the part from a model, and then I'm going to measure it to qualify it against the model to make sure that it's a good shape. So let's go ahead and get started. Okay, the first thing I'm going to do is clear the project and get into what's called VTube step mode, which is a different window that allows us to import step models. So I'm going to bring in a step file of this part. And now you can see that we have model information that we can use then to figure out the center line of this part. Let's go to Collected Features, Show Collect Control, and we are going to use rectangle from corner fillets like this. All right, we're going to rebuild the center line of this part. And now you can see we have the parametric data for the model that was imported. And now we have a model that we can use to compare with the part that I have on the table here. So let's get back into VTube laser mode now. And let's go ahead and prepare to measure this part. Okay, so now what I'm going to do is measure the part using what's called corner profile process measure. And the reason why I'm going to do that is because I want to intersect the two planes all the way around one corner. And then I'm going to take the intersection of that all the way around, and then I'm going to average it with the intersection of the other side by measuring the corner profile on the other side as well. We call that measured tube averaging. So we're going to get a center line here and a center line here, and then we're going to average the two together and get the true center line of the part of the model that we imported. So I'm scanning both planes at the same time. Now I'm going to press finish and build and measure again. Now I have to turn the part so that I can get to the other corner we measured here. So now I'm going to have to measure here. So let me just keep that in mind. And so measure here. So we've already measured here, so we have to measure here. And yes, I can get to all the corners on that orientation. Let me just make sure I can reach everything. Yep, I can. I just have to watch that right there. Make sure that I don't make a mistake in hitting the tube while I'm measuring it. All right, so let's go ahead and finish an average. And we're going to take the last two. And then we're going to perform an alignment to see how well this part works. All right, let's change our tolerance to maybe 125 thou, or inches. Yeah, there we go. And so you can see the part is in tolerance if we use 125. when I reversed engineered this part, I guessed regarding the angles and the intent of the lengths and all of that. I made these nominal 90s, and I made these both the same angle. So I'm not sure what the master model is. So I'm not quite sure how well this part actually qualifies, but I can tell you that according to the model that I created, it qualifies at 125 thou, except for the very end. Now let me show you what happens at the very end here. In fact, let's go over to part setup. And let's see here, 1.5. Let's just set the diameter so you can really see this. You can see right here that according to the model that I made, the nominal, this leg right here is going that way. It's inside. And now let's just assume for a moment that my model is actually your intent when you designed the original model for this part. Then what we would have to do is we certainly have to make a correction of the bender for that. Let's go over to bender setup. This is where if you had a connection to the bender, you could automatically correct the bender. And you can see the white columns, they have the adjustment values. And if you send all of those adjustment values over to the bender, they go over in the orange columns like this. So you perform a recall and you get the blue columns from the bender, okay, whatever the setup is, and then you send the orange columns over like this. The orange columns will represent the new bender data that you would use to bend the next part to, of course, change the shape so that it actually fits the model, whatever that model is. You could also go into reports and go to, for example, bender corrections only, and get to the adjustment data here. And some customers, they'll print this out, or they might take a telephone and snap a picture of the corrections and walk over to the bender with that data and enter the corrections in by adding it into the bender data and then bending the next part and bringing it back and measuring it again. So that's how you measure and qualify a tube shape like this after having imported the master model or the nominal model. If you have any questions, please feel free to email me at michael.cohn@advancedtubular.com. Thanks for taking the time to watch this demo. Have a great day.